Greetings folks and welcome to the Electromaker Show. This is your midweek roundup of all things maker and embedded and lovely. Now, we missed a show last week, so we have a bumper show this week of an amalgamation of stories from last week and this week to get through. So let's not waste any time and get started with the show. We're going to start with a couple of projects and a tutorial that I saw over the last couple of weeks that I thought were notable. And we're starting with graphing calculators. So you, like me, probably had one of these graphing calculators at school, and they've always been capable of kind of amazing things for their size and for their processing power, but this is amazing. This is a TCP/IP stack that's been written for this calculator, and this calculator can natively connect to IRC chats, so you can just chat on a calculator. It's incredible. It truly is. The video itself is very short, and I'm not going to show all of it. You can find a link to it in the description of our video. But as you can see here, yes, this is someone chatting on and it's going to say the name of the calculator too. So this is a video by Tobias Madel, and he has also given the code. It is available on GitHub, and this shows you how you can install it onto said calculator if you have one. As I say so often, I am a big fan of taking pre-existing hardware, maybe from the past, and giving it a more modern spin. I'm not saying this is the most practical project in the world, but it's certainly very cool. Moving on to the Arduino blog and HamMessenger. This is a project that allows you to send text messages over ham radio. Now, I would be quite interested to hear in the comments of this video if any of you are radio enthusiasts, because I know there is quite a crossover between the hobby electronics world and the amateur radio world, and I know there are many hacks and things using Arduinos and software-defined radios that are part of that world. It's something that I've never really delved into all that much, although my father was a very keen amateur radiographer. That's not the right word for it. He was into amateur radio. But yes, this is a really nice project because it basically leverages the fact that ham radios can do more than just send audio. You know, you can send data over over an audio band, because if you've ever used a dial-up modem and heard it ring out, those noises you're hearing is data sent in audio form. By the same token, these packages can be used to send text from one radio to another if they have a display like this one. So in short, it all works via this little custom shield here. The custom shield has a Pro Mini on it, and I believe that is just being used for sending APRS messages. It's sort of acting like a mini modem. The star of the show is a Arduino Mega board hiding underneath here. This is a shield sitting on top of it, and a GPS module and a little OLED here you can see for whatever message you want to send, along with one of these quite handy little M5 stack cards, which is basically a keyboard in credit card form. So you can see there's a mock-up here as well of how the shield fits on top of the Mega with the different devices as well. There's the little ceramic antenna for the GPS system, which in this top image is actually off here. This is a lovely project. I'm not going to spend any more time on it actually on the show, simply because it's been written up wonderfully on the Arduino website in brief. And if you would like to know more about it, there's a link here to the GitHub page, which goes into a great amount of detail. I'm looking forward to later reading into this a little bit more, because it seems like such a wonderful project. And as I said, it's something that I am tangentially attached to, because there was always radio equipment around my house when I was a child. Yeah, something that I haven't really looked into as an adult yet, but wonderful project, and I will of course link it in the description of the video. The next project I want to cover is not one, but two videos. One by Sam, as in Look Mum No Computer, who I'm sure you are all familiar with. He is become one of the most famous names in DIY analog synthesizers and crazy inventions, and absolutely deservedly for good reasons. He's been making beautiful things for many years. And also, as Stephanie Explains It All, someone who we've also featured on the show before. And this is a project that they have worked together on, and this is to turn cryptocurrency markets into a synthesizer. So I would recommend watching both videos to get the proper context for this. Stephanie's video is very much more relevant to this show. That is taking a Raspberry Pi, using it to get information, regular information about Bitcoin and various other cryptocurrencies from APIs, and turning those figures into usable PWM voltages, or just voltages outputted on the pins. I can't remember if it was using PWM or not, but that's something you'll have to watch the video and find out for yourself. And of course, once you have voltage, then you have music in the world of analog synthesizers. And this is where Sam's expertise comes in, because he has spent many, many years making wonderful synthesizers that work in varieties of ways. If you follow his channel, you know exactly what I'm talking about. And so with a little bit of smoothing, of course, done once again, analog, this Raspberry Pi sends data out to all these different self-built oscillators, and each oscillator gives a tone based on how high or low any given cryptocurrency is at any time. And if you're wondering how it sounds eerie and kind of beautiful. So a 2-for-1. I will leave a link to the Look Mum No Computer video in the description of my video, because then you can go to this one video and go down here. And the first link here is the Stephanie Explains It All video that I've also showed here. Also, if you are interested, there is a 1 hour long version of that little clip I just played you of the cryptocurrency synthesizer. And while putting this show together last week, I listened to it. And if you are a fan of ambient, slow, drone-ish music, which I am, you might enjoy this. I certainly did. Now, we talked about RISC-V on the show a lot. It is the new buzz, it is the new excitement, but there's one thing that I frequently get asked by people who are tangentially interested in the show, or just kind of getting into hobby boards, and the main thing they just ask is that you've explained a couple of times kind of why RISC-V is exciting, but I still don't really understand what it is. And luckily, I have an article that may help you if you are in that camp. And that comes in the form of this article by Abhishek Jadhav on the Electromaker website. This is What is RISC-V? And it is a fully detailed article telling you exactly what RISC-V is, what makes it interesting, the difference between instruction sets and microarchitecture, what it's used for, and of course the all-important things. It is an open-sourced instruction set architecture, which means that if you're using an open-source license with RISC-V, you do not have to pay anything to use the instruction set, which is not the same with other chips. So yes, what is RISC-V? You can find out here, and I will leave a link to it in the description of the video. Before moving on, a very quick piece of housekeeping. If you are not already subscribed to the Electromaker YouTube channel, please consider doing so. Just under the video here, this subscription button, you click it, then you are subscribed to our channel. Now, that doesn't mean that you're going to get spammed with notifications from us. It just means that when you go to the subscriptions area on your channel, videos will show up. As it happens, this is the only thing that this channel is subscribed to, so there's quite a lot of me in there, but every subscribed video will be here in a nice digest for you. Now, one thing you can do if you really are enjoying the show is sign up for some notifications, and you do that by clicking this little bell here and selecting All. Now, that won't give you desktop notifications unless you've enabled them in your browser, but it will mean that this little notification bell here in the top right will be populated with the shows that we put out. Every time we upload to the channel, you will get a little notification here. However, we upload once a week only to the Electromaker channel. Typically, there are exceptions to that, but mostly once a week. So you will come to YouTube, you'll have a little nice notification mark here, and you will see a show has gone up the moment that it has. And of course, if you like the show, clicking like is very useful too. It doesn't just show us that you like it, but it shows YouTube that you like it. And in fact, all three of these things are really a way of you telling YouTube that you like the show enough that you think it is worth sharing, rather than telling us directly. It does really, really help us. So those three things are things that you can do to help us on YouTube. And there's no obligation to do any of it, but if you do, it will help us a lot. We also have a Discord server, and you can find a link to that in every single video, along with on the Electromaker website. It's free to join, anyone can join it, and we're looking forward to it becoming a nice community where people can share things they're working on and generally chat, and maybe help each other out when they get stuck on a bit of electronic projects and coding and things like that. And finally, we have a shop. I know some of you have been heading to the shop already to get components for your maker projects. It is massively appreciated. This is definitely the best way that you can support us. It is a direct financial contribution to the show. But in general, if you are supporting the show in any one of the ways I've just said, I would like to thank you so much. This channel is growing quite quickly, and it is very, very nice to see, and it is thanks to you showing us support, so thank you very much for that. But anyhow, let's get on with the rest of the show. It is time for funding website things, and today we are returning to CrowdSupply to look at two different pre-launch projects. And the first of these is Chhavi, or Chhavi. I'm not sure quite how you're supposed to pronounce a double H like that. But what it is very interesting. This is a wireless open source ESP32 based fingerprint sensor with near field communication. And look at it. It's such a lovely compact little idea. There's your fingerprint sensor. There's your tiny little ESP32 board, and it's just designed to be an in-situ thing that you can use. It's a really interesting concept and a really nice way of developing things like fingerprint recognition in an already usable package. Although, of course, I am not clever enough to know how secure that would be. But yes, this is, as you can see, is a pre-launch project, as I mentioned it was going to be. And yeah, touch capacitive, wireless NFC-enabled fingerprint sensor with ultra-low power and high-end security capabilities. So what I said before about security, I'm going to safely assume that I have no idea what I'm talking about. There's also a quick demonstration video here that shows it in action, shows the web interface that allows you to enroll new fingers along with a bunch of other tasks. And the features and specs are of course available on this page as well, so I'll let you come and have a look at it yourself if you are interested. But this is the quite lovely little custom PCB for it, and it is very, very compact and just in general a very nice idea. As with most things on Crowd Supply, this is going to be an open hardware and software project, so you can already look at where they are on the GitHub repo just here. There's yeah, I'll be really interested to see where this one goes when it goes live. This is a kind of, this isn't really your normal hobby DIY kit, but it really is more kind of like a ESP32 development kit, but specifically for things to do with fingerprint, NFC, and capacitive touch. A really interesting project, and we'll be coming back to it when it goes live to see how much it costs. But yes, Chhavi or Chhavi, a NFC-enabled fingerprint sensor with Wi-Fi built right in. Moving over to IoThing Digital. Now this is a complementary board for working with IoT. In and of itself, it doesn't have a microcontroller on it. It's designed to work with a microcontroller, either through the micro bus slot you can see here, or by attaching to it separately. But the really interesting thing here is, as it says, it has 2 high power relays and 2 isolated AC or DC input channels of up to 300 volts. So this is working in a much wider range than most hobby microcontrollers are already. Now, the eagle-eyed among you may have also noticed that there is a Grove connector attached to this thing as well. There's various ways of talking to it. As it says here, there's going to be various add-ons. So it can be used as an add-on module for popular system on modules such as the Raspberry Pi. And then presumably you do that just by attaching to some of these pins and making your own connections as you would with any other breakout board that doesn't fit directly on top of the Pi. But as you can see here, there's going to be some micro bus breakouts with different chipsets on it. The SAMD21, along with a couple, there's an STM32F4 and LPC824 as well. So there's a bunch of features and specs here, but as I mentioned, I think one of the things that will make this most interesting for most people is just the sheer variation of power that this thing can take without it getting fried. As you can see here, it can take 3 amps of up to 30 volts of DC current, or 3 amps of up to 250 volts of AC. That's quite a lot of power you can pass through this thing. And of course, there are a couple of other nice things. As I previously mentioned, there's a Grove connector here for I2C. These will presumably be things you can buy separately when it goes live. So much like the last one, I'll leave this as it is for now. If you're interested in either, you can come to their pages and sign up for news. Although, as I mentioned, I will probably come back to both just to have a look at them when they actually go live and there's a bit more information. It is time once again for the mystery box competition, and this is the mystery box. It says it right there, and it was provided to us by the wonderful people at Mauser Electronics, which it says right here. And the mystery box competition is quite simple. If you leave a comment on one of our videos, in the next week's show, I will pick something out of this box to give to one random comment from the video from the show before. I hope that made sense. But now it's time to pick a prize. So I put my hand in the box, and I pulled something out of the box, and it is, oh, it's one of these little Cypress semiconductor boards. Okay, hang on, let me put the box down and have a look at this. So I have brought in Quality Camera 2 to have a quick look at this, but in short, as you can see, this is a small development board with one of the PSOC4 chips from Cypress on it, with a little USB serial connector, which you can snap off and turn it into a completely separate thing and just use it to program the board when you want to program it, or leave it attached and program this thing directly via the USB ports of your computer. As you can see also on the screen in front of me, I have the datasheet up with a bit of information on it, in short, this can do a lot of the stuff that other Cypress semiconductor boards that we've talked about on the show can do. It has capacitive sense built right into it, which is kind of cool. It means that if you want to do something that detects when your hand is near, you just need to put a single wire into a GPIO port, or one of the GPIO pins, sorry, of the board, and you have capacitive touch. And you can do that even when it's just attached via USB. You don't have to separate this thing out. By virtue of the fact that the USB serial drive is attached to it, I know you can technically do this with any hobby board, but I just feel that it's quite a nice compact idea that you can plug this into the computer and then attach, well, anything that works via I2C or SPI. You can attach a screen or anything to the USB port of your computer and really work out how to use these kind of PSOC chips with your hobby, or even you're doing something a bit more professional work. Yeah, it seems like a very convenient way of doing things. Anyway, this is definitely waffle, but in short, yes, it has capacitive touch sensing, and yes, you can use this USB breakout with or without it. You can just use it as a programmer or use it to directly control the board. It has a few other nice features as well, and we're going to send it out to one of our viewers. And our Mystery Box Prize winner, chosen at random from last week's comments, is Adelbear. So, congratulations. And by the way, I would also really like to try the new ESP32C3S board, the RISC-V single core fun. I may have ordered a few of the ones I showed from AliExpress a couple of weeks ago. They may be arriving in a month or so. So, yeah, I might be showing them on the show again. Anyway, for now, congratulations. We'll be in touch with you as to how we can send you this prize. And we should get on with the rest of the show. We're going to finish this show with a very quick whip through of a few academic-themed projects and a couple of new products. And by the way, I apologize in advance if there's any background noise. I've had to open the window, it's just far too hot here. But it does look like the chainsaws have gone away for a while. We're starting with the winners of the Astro Pi competition. Now this is from the Raspberry Pi blog, as you can see, and this is possibly the coolest sounding competition I have ever heard of. This is this allows students to submit codes to a competition to run on a Raspberry Pi, but that Raspberry Pi is in the International Space Station, actually orbiting the Earth. One of the coolest things I've ever heard. And yes, essentially there is a Raspberry Pi up there which has its own custom hat with a bunch of different sensors on it. And presumably the way it worked is that each school would be given a similar setup so that they can try prototyping their ideas on Earth before simply sending the code up to the ISS and letting it work that way. And I have looked at a lot of these winning entries and they are just incredible. Some of them are just so inventive. Some of the ideas are incredible. So as a brief rundown, I'm not going to spend time going through them. I don't have the time now, but using machine learning to take photos of the clouds and the sea and the ground from above, and determining whether there are clouds there, whether it's sea, whether it's land, and what that means about weather patterns. That's one of the projects. Another one is data sonification, using various sensors and accelerometer sensors and GPS location from the ISS and turning it into music using data sonification. Just so many wonderful projects. I will link this in the description, and there's a lot to dig through because every single one of these links you can see here links out to a project, and you can see the write-up of it, how it worked, and almost all of them have links to examples of, say, imagery or music depending on what the project was about. Just a wonderful thing. This is the best thing I have seen in weeks. Moving over to the Arduino blog with a NFC academic project. Now this is weaving NFC into regular fabrics and using it to determine the position in a room where certain objects are. Not just objects with NFC tags, but things like human hands. So this isn't using capacitive touch. This is using NFC directional sensing to sense whether a hand is in a certain position or not, and as you can see, using it in a sort of smart home sense. Now, as the blog post mentions, it uses beams of radio waves using the same multiple input and output array for a lot of other forms of connectivity. There is actually a link directly to the paper here, and I've read through the first 5 or 6 pages of this, and it's absolutely fascinating. And if you're a little bit concerned about diving into academic papers, I fully understand. I usually get very lost very quickly, but this is wonderfully written, goes through the core concepts very, very well in a way that is very easy to understand. So I will link the Arduino post in the description, and you can get through via this link down here to the actual paper itself. Up next in our academic themed projects section of this show is this thing on Stanford News. And as you can see, this is someone with a Raspberry Pi on their hip, along with a little battery and a couple of sensors. This is a project from Stanford engineers for giving a much more accurate calorie counting way of doing things rather than a smartwatch or a smartphone. Now, as you can see, this is a Raspberry Pi with an extra little breakout board on the top, along with a battery bank. And yes, they do provide instructions as to how you can build this thing yourself. These instructions are in the article, which I will link. You can see as well, there's an inertial measurement unit at the top of the leg and the bottom of the leg, and that's the crux of this idea. Helicopter. Put simply, this project claims that 2 sensors, one at the top and one at the bottom of the leg, is a much better way of reading actual calories burned, as in how much work you are doing, than a combination of a heart rate monitoring on a smartwatch or step monitoring through a smartwatch or a smartphone. As mentioned, they give you a list of components and the code you need for making it yourself. It is all linked on this article, which I will link in the description of the video. So our final stop on this rather fast-paced last section is the Matrix Portal ESP32S2 from Adafruit. Now, this is just a picture of a PCB, and I understand that might not be all that interesting, but this is an updated version, a coming soon version of the Matrix Portal, something that I am very interested in, because as you can see, that is a Hub 75 panel. In fact, this is also a Hub 75 panel. That is the Hub is just the name of the type of panel it is. They all work much the same way. Now, I've got a bunch of these. I bought a load of them cheap a while ago because I thought it'd be a very cool thing to do something with. I've got them out a few times to fiddle with. I haven't come up with a final project for them yet. I am tempted, rather than using an Arduino as I was doing before with a bunch of extra breakout circuitry, to get a new version of this board when it comes out. Because in short, this is designed specifically for working with these kind of panels. It plugs into the back, as you can see here, and it just works. But the reason I'm showing you this one is because this is the newer version of it, because this original one uses two separate chips, an ESP32 chip and a little Atmel, one of these SAMD chips, AT-SAMD51J19, I believe that says. But this is going to be a thing of the past that is being phased out, because the ESP32S2 can do the job of both of those chips, and this board is going to be exactly the same, but just uses the one chip instead. So there's no further information right now other than that it is coming soon, but as you can see, I have a good reason to maybe get one of these things when it lands, and when it does, maybe we'll find some way of featuring it on the show. That was our show for this week. Thank you so much for joining me, and thank you for all the support you are showing this show, whether that's on YouTube here, or by joining the Discord, or by buying things in the Electromaker shop. It is much appreciated. So I will see you in the next show, but for now, I hope you have a fantastic, safe, and creative week, and I'll see you then.